there's what we got with U substitution. I'm going to go back to the original. All right. So what I'm going to do instead is I'm not going to use U substitution. I'm going to use that extended power rule. Does everybody see that 2x squared plus 1 is my f of x? So I've got an expression to a power. So what does that extended power rule say I do? What happens to this power? Comes where? Down front. What happens to this expression? It stays what? The same. I do not touch it. What happens to your power? So that gives me a what?
13.
Now, if you're going to do this, though, you cannot forget this step. And the step is you have to have the derivative of the inside. So what is the derivative of this inside?
4x.
4x. It's one extra step. So sure enough, when I say 14 times 4x, I do get 56 what? Which is exactly what I got doing U substitution. We're good? Question?
Are there times when that will work where U substitution wouldn't work, or vice versa with the power?
If what you're doing right now, both should work. Now, I can think of some times, I'm trying to think of a single time in Cal 1 where I can't avoid it. I can't think of a single time. There probably is one, but I can't think of it. But I can think of a lot of times in Cal 2 where you can't avoid U substitution. So that's the reason where you really need to learn to use it when it's easy to use, so that when you have to use it, you're not just caught. That's why I would practice it a little bit. Okay? Look over here, same thing. If I don't want to use U substitution, if I want to use the extended power rule, what happens to your power? Comes down front. What happens to your expression? You were tired of me saying this. What happens to it? Stays what? The same. I do not want a funky combo of something. What happens to your power? Goes down by 1. So it's going to go down to what? Now here's the part you cannot forget. What have you got to do now? Take the derivative of what? The inside. Now, this is the inside. Over here, this was the inside. So over here, the derivative of this inside was simple. The derivative of this inside ain't going to be so simple because what is it? It's a what? It's a quotient. So if it's a quotient, you have to use what? Quotient rule. So when you do the derivative of the inside, you understand it's like starting a whole new problem. So do I start top or bottom? I start what? Bottom. I do the derivative of the top, plus or minus on quotient rule. Minus. Then I copy down the top. I do the derivative of the bottom, which is what? 1. All over the bottom what? So I end up getting exactly the same thing I got before. I just have to clean it up. Now, let me tell you what, to me, this is exactly like. I mean, look what you're going to have. You got that 6. You understand that this 5 goes with both of these? So this is a 5x plus 3 to the 5th over an x minus 1 what? To the 5th. And then I've got 5x minus 5 minus 5x minus 3 all over x minus 1 what? Squared. So sure enough, what happens to this 5x and that 5x? They're going to subtract out, and I've got a negative 5 minus 3 is going to give me that what I saw a minute ago with your substitution, that negative 8. Well, that negative 8 times that 6 is going to give me that negative what? 48. Well, there's 5x plus 3 to the 5th. And sure enough, I have 5 down here and 2 down here, which makes I have any. 7. Now, before we do these other two, here's kind of my analogy. One of the hardest things for students a lot of times when they're taking algebra is factor. Because at the very beginning, when you do one thing, you're finished. You know, when you first started factoring, it'd be like 3x minus 6, and you pull out a 3, and you're done. Is everybody with me? Then later it turned into things like x squared minus 9. And again, you learn to do x minus 3 and what? But then it started turning to things like 100 x to the 4th minus 81 y to the 4th. So then when you ended up doing things like 10x squared minus 9y squared, and then you'd have like 10x squared plus 9y squared, and then you got the difference of squares, you had to keep going. Is everybody with me? So you'd have problems inside of other what? Problems. It's the same way here. It used to be one step on derivative and what? You were done. And now that's not going to be the case. There are going to be derivatives inside of other what? Derivatives. But as long as you just look at them separately, I mean, it's like starting over. Is everybody with me? I got the difference of perfect squares, like starting a whole new problem in this problem. So the same thing is true up here. When I have a quotient inside of a power, I have to do a power rule. In the middle of the power rule, I got to do a quotient rule. Now, let me show you on your sheet. Glance down at the bottom. Okay? Do you see where it says the derivative of sine of an angle? What's the derivative of sine of an angle according to your sheet here? It's what? Cos of that angle, but there's one extra step on all of these. What does it say? The derivative of the angle. That's the only extra step. So look right here. If I don't want to do u substitution, I don't have to. What's the derivative of tangent of an angle? Secant squared of that same what? Angle. I've got one extra step times what? The derivative of your angle. It's like starting a whole new problem. What's the derivative of 4x? 4. So sure enough, I'm going to get 4 what? Secant squared what? 4x. You can do one extra step. That's what you've been doing the whole time. See, what if y was just 10x? What's the derivative of 10x? On your pop test, hopefully you told me it was what? Secant squared x. Why? What's the derivative of every one of your angles so far? 1. You've just been doing the special case the whole time. Because the derivative of your angles were always, your angles were just x's, so your derivatives were always, of the angles were just what? 1. They were trying to teach you that the derivative of tangent was what? Secant squared. They're trying to get you to memorize the forms. All right? It's the same thing you're doing on power rule. So the first thing we did was something like x to the 4th, and what did you tell me the derivative was? 4x what? Here's y. The power came down, your expression stayed the same, and the power went down by 1. What's the derivative of this inside? Every time it was a what? A 1. So again, when you were doing power rule before, you're really doing just the special case. The derivative of your inside was always 1, or the derivative of your angle was always what? 1. Same thing on E. So look at, on the sheet, let's see where I put the sheet. All right, look at, and we'll get to the number 7. Look where it says special case. We'll talk about the unspecial case in a second. All right, it says the derivative of e to the f of x equals e to the f of x times what? F prime of what? Of x. Now, we're going to talk about logs in just a minute. But this one pops up more than any other. So sure enough, if you've got e to a power, what's the derivative going to be? It's going to be e to that power. What's your one extra step? The derivative of the power. And what's the derivative of that power? So that's why we got 6e to the what? 6x minus 1. See, before you had y equals e to the x, right? Well, what's the derivative of e to a power? It's e to the power, and then what's the derivative of the power? It was always what? 1, just wasn't showing. So I can avoid u substitution. Now, I do want to make sure we're clear about something. Let's kind of go back over here. Now, do you see that number 5 is just your quotient rule and number 6 is just your product rule? Is everybody clear with that? Now, let's make sure we understand the difference between rule number 4 on your sheet and rule number 7. These are not the same thing. They're not the same function, so they're not going to have the same derivative. This has nothing to do with power rule. Everybody with me? This has to do with power rule. That's why on number 4 it says note. Rule number 4 is a variable to a what? Number. That's power rule. Number 7 is a number to a variable. So look what it says your derivative is. All right, this is kind of a new rule. If you've got a number to a variable, all right, your book calls it like an A to an f of x. All right, look what it says the derivative is. First of all, what are you going to do? You're just going to copy back down the what? The number to the expression. Then you've got to do the derivative of that variable power, and then you've got to do the natural log of that numerical base. So I've got to learn that formula. So if I gave you this on a test and said, what's the derivative? What's the first thing I'm going to write down? 2 to the what? X. Times. Why 1?
So that's the derivative.
That's the derivative of the power. Times what? The natural log of what?
2.
Now the natural log of 2 is not a rational number. Is everybody with me? So you can change the order of that, but you can't really make it look a whole lot better. So my derivative would just be the natural log of 2 times 2 to the x, whichever order you prefer. Now look at why E is a special case of this. Isn't E a number?
Yes.
What's E approximately equal to?
2.7.
All right. So if I give you something like E to the 5x plus 7, and I say, what's the derivative? That's not power rule. That's a number to a variable power. So what's my derivative going to be? It's going to be that number to that same variable power times what?
Derivative.
The derivative of that power, which is what? 5 times what? The natural log of that numerical base. But what's the natural log of E?
1.
1. So this part never shows up. Is everybody with me? You can write it down, but that's why over there a minute ago I didn't write it, because the natural log of E is just going to keep being what? 1. And the numerical base that you see the most is E, not 2 or 7 or 8. So you're going to see E's more than you see 2's or 5's or any other number. So if you have E to a power, it's just E to that power times the derivative of the power. But that's why on the sheet, the ln of 1 just kind of crossed out there, because that's just a 1. Now, let's talk about these log ones for a minute. I'm going to do a general one, and then I'm going to do the most common one. So the log that's going to pop up the most in your books is going to be natural log. But you can have a log base 10 or log base 2. Is everybody with me? Now, I told you back several weeks ago that if you didn't learn these rules, back on page, let's see where it is in your books, 56, you're going to make your own life miserable. Here's when the misery begins. So look what it says your rules are. Now in your books, they've got the derivatives of the natural logs on page 160. All right. So I'm going to do natural log first, and then I'm going to back up and do all the logs are on page 162. So look what it says on page 160. It says this, and it says it on the sheet. If you've got the natural log of f of x, and you're supposed to be taking the derivative of that thing. That's f of x on the bottom and its derivative on top. It's not the quotient rule. They're not the same thing. So what that means is this. If your function was the natural log of something simple like 8x, and I told you to take the derivative, what goes on the bottom? Look at the form. The function. So what goes on the bottom? 8x. What goes on top of it? The derivative of what you just wrote down there, right? So what goes on top of this? 8. So what does that clean up into?
100x.
So we understand it's a quotient, but it's not quotient rules. Everybody with me? But look at why, if you didn't memorize those rules on page 56, you're about to make your own life bad. What goes on the denominator? All that, the original function. What goes on top of it? The derivative of that thing. So what rule are you about to have to use? Quotient rule. So I'm about to have to put x plus 7, what's the derivative of the top? 6, plus or minus on quotient? Minus, then I copy down the top. I do the derivative of the bottom all over the bottom what? Square. So now what do you got to do to this algebraic disaster? You got to simplify. Or you could have learned the rules on page 56 when I told you to learn them. Because if I know the rules on page 56, life is great. Don't you have a rule on page 56 that says you can change the form of the log of a quotient? What can you change it into?
6 plus 3.
The log of the numerator, what? Minus the log of the denominator. That was on test 1. I would much rather take the derivative of this form than that form. Because now all I've got to do, what's the derivative of the natural log of 6x plus 3? What goes on the bottom? 6x plus 3. What goes on top of it? The derivative of what you just wrote, 6. Minus, what's the derivative of this natural log going to be? What goes on the bottom? X plus 7. What's the derivative of that? 1. I'm done. Everybody with me? That's why learning those rules on that page are going to make life a whole lot better. I would much rather do this than clean up this. Now, when you turn to the back, they likely have gotten a common denominator, but this is good enough for me. We good? Now, they do remind you in your book, and this rule on page 8 does remind you, what if it's not natural log? What if you have a log with base b of some function? All right. So look what it tells you that you get. Again, you get your function on the bottom, whatever follows the log. You get the derivative of that thing on top of it. Everybody tracking with me? Your one step is you have 1 over the natural log of your base. That's your one extra step. So what if I had this? What if your function was log base 10 of 2x plus 3, and I told you to take the derivative? What goes on the bottom? 2x plus 3, very good. What goes on top? Does everybody see where the 2 came from? The derivative of the denominator, what you just wrote down. What's my one extra step? I've got 1 over the natural log of what? Again, which is not a pretty number. There's not really much way to clean that up. I can make a single fraction out of it. I can just say that's 2 over the natural log of 10 times 2x plus 3. About as good as I can make it. All right? But do you understand why this is the form that it's in? See, if I had this, what if it was the natural log of 2x plus 3 instead of the log base 10 of 2x plus 3? Well, what's my derivative going to be? What goes on the bottom? 2x plus 3. What goes on top? The 2. Now, I've got 1 over the natural log. Everybody with me? Now, what is natural log? Isn't natural log mean log base what? E? Isn't that what ln means? So do you understand I'd have 1 over the natural log of E. And what is the natural log of E? 1. And 1 divided by 1 is 1. And anything times 1 is that original what? Thing. So that's why when it's ln, all you got to worry about when it's ln is you got the original function on the bottom and its derivative sitting what? On top of it. When you have e to a function, your derivative just e to the function times the derivative of the function. But when you've got a log that's a different base, or if your base is another number besides e, then it gets 1 extra step. That's all your explicit derivative rules. That sheet. And that's where your test material stops for your second test.
We don't get to use this sheet, do we?
You can't do the next week. Okay, now, am I going to care if you use U substitution? What? No, that's completely up to you. So let me let you practice a couple things real quick for me. Now, your test is going to be